Hey guys, welcome back. We'll continue with the book Python for Data Analysis. In this video, we are going to cover how we can read and write datasets using pandas. If you want to follow along, feel free to subscribe to the channel, and let's jump right in. Let's cover how we can load data and work with different file formats. To follow along, you can head over to wesmckinney.com/book and read the book for free. We're going to start out by learning how we can read and write data in simple text format, and then we're going to cover some additional ways to load data. First of all, how we can load binary data formats, and then we're also going to cover how we can interact with web APIs to read data from the internet. Finally, we're also going to cover how we can interact with databases. Pandas offers a wide number of different functions that we can use in order to read tabular data as a data frame object. There are a number of different text and binary data loading functions that we can use. Here's a table that summarizes those functions. We have, for instance, read CSV, which can be used in order to read a CSV file. But we have additional functions such as the ability to read an Excel file. Let's start out with an example, and we're going to use one of the examples files provided by the book's resources. So if you haven't already, feel free to head over to the GitHub page, link also in the description down below. And let's head over to code, and here we can download the book's resources as a zip file. Once we've done so, we can unzip the file and then move it to the locations that we're working from. And as you can see, one of the folders here is called examples, and this includes examples we're going to use moving forward. Now to start working with an example, let's open up our terminal, activate our conda environment, and then we can activate IPython. And let's start with a simple comma-separated CSV file. For that we can enter this command, !cat, which is going to display the contents of a file. And then inside of the examples folder that we downloaded before, we're going to have a look at exercise1.csv. Now this file contains the following content here, which is separated by a comma. Now quick note, we're using cat, which is a Linux command that will work under Linux and Mac. If you're working on Windows instead, you can just replace that command with type, and the rest should be exactly the same in order to display the information. Now since the data inside of that file is separated by commas, we can just use pandas readCSV function in order to read the information and save it in a variable. To do this, we of course first need to import pandas, and then we can go ahead and we can call readCSV, which is again part of pandas, and we're going to pass the folder as well as the file as an argument to that function. And this is going to create a new data frame object. So if you have a look at our object that we created, we can see that we created a data frame where we have a header row here, and after that we have the individual rows which have their own index at the beginning, and then of course we have the different values which were comma separated. Now a file will not always have a header row, so for instance we can have a look at another example, in this case exercise2.csv, and in order to load this file without a header row, we can use pandas readCSV function again, and as an optional parameter we're going to set header to none. So in this case we can see that the first row here inside of our file is not used as a header row. Instead we have the index displayed from 0 to 4. We can also specify a header row ourselves. For that we are going to use our readCSV function again. And we're going to use the names attribute here in order to specify our own header rows. So here we're going to use the labels A, B, C, D and messages. If you have a look at that, we can see that's exactly what is being used as a header row for our data frame. In the examples that we looked at so far, the different values were always separated by a comma. But that's not always the case. So if we look at another example here, exercise 3, we can see that in this case here the data is not separated by a comma, but instead by white spaces. And we can see in some cases there's a single white space, and in some cases there are multiple white spaces separating the different values. So in such a case we can use a regular expression. Specifically we're going to use our readCSV function again, providing the path to our file as an argument. And then as a second argument, we're going to specify the separator. In this case, we're going to use a regular expression \s+, which is going to match one or multiple white spaces. So if we now have a look at our result, we can see that we have our data frame here, and that's properly separated based on the white spaces. Now we can also decide to skip certain rows when we read our data. So as an example, let's look at example 4 here. And in this data file, we can see that we have some comments that have been added. In this case, we don't want to read them because we only want to work with the actual data. So to ignore those rows, we can go ahead and we can call readCSV with the respective path. And then we're going to add skip rows as an additional argument, and we're going to specify the index of the different rows that we want to skip. So we want to skip the very first row, the comment here. So that has index 0. Then we're going to include the row with index 1, but we want to exclude the rows with index 2 and 3. And those are exactly the numbers that we provide here inside of our list. So if we have a look at that, we can see those rows are indeed ignored, and instead we just included all the other rows inside of our data frame. Now when we're working with real-world data, a lot of the times the data is going to miss some values. So let's have a look at another example, example 5. And here we can see there are certain values not included, so they are missing. And of course there's a way to deal with that. So if we read in our example file here, we can have a look at the resulting data frame, and we can see that those values that are not included are specified at NaN, so not a number, and therefore signifying that the values are missing in this case. And as we saw before, we can use pandas is not a number method in order to have a look if a certain value is not available and therefore missing. So in this case, there are 2 values that are missing. So this returns true and all the other values are provided, so we get false back. So the read CSV function that we just worked with before is used quite often and has a number of different function arguments. So we already saw, for example, the SEP argument for the separator, where we specified, for instance, that we want to use a regular expression to use white spaces as a separator. And we also covered skip rows in order to skip certain rows. But there are a number of additional arguments available, such as, for example, the header argument to specify the row number to use as the column names, or for example, parse dates when we want to work with datetime objects. Now, when we're working with very large files, we may want to decide to only read a small part of the file. So for an example, let's switch over to our terminal. And before we actually look at an example, we are going to adjust the settings for pandas so that we have a more compact view. So here we are setting the maximum rows that are displayed in pandas to 10 in order to not get overwhelmed by the output. After that, we're going to use our read CSV function in order to read in another example file, example 6. And if we have a look at our result data frame, we can see that we have a result with 10,000 rows displayed here. Since we specified our settings to only display 10 rows, we can see that the first 5 rows are displayed here. Then we have a row with 3 different dots, which basically shows us that these are rows that are excluded from the results. And then we have the final 5 rows displayed here. Now, if we don't want to read in the entire file here, but only certain rows, then we can go ahead and use the nRows argument here, which specifies the number of rows that should be read. So in this case here, we are only going to read the first 5 rows. So in the result, we can see that only the first 5 rows are included and all other rows are ignored. Now, when working with a large file and we want to read in the file in small pieces, we can use the chunk size argument. In this case, we specify that we want to read this file in chunks of 1,000 rows. Now let's have a look at the type of our file that we look at. And we can see it's of type text file reader. And since this file is of type text file reader, we can iterate over parts of it according to the chunk size that we specified before. So to do that, let's first of all specify a new series object with a data type of int64, and it should be empty at the beginning. And then we can use a for loop in order to loop over each row inside of our chunker object here. And for each row in our file, we are then going to count how often a key occurs, and we're going to specify the fill value to be 0. Now finally, we're going to sort our values in descending order so that we have the highest value at the beginning with the key that occurred most often. So now if we have a look at the result, we can see that the key E occurred 368 times, then X, and so on and so forth. And just as a reminder, if we have a look at our result again, we can see that inside of that file there was a key column here with letters such as L, for instance. We can see this occurs multiple times. And what we just did is iterate over each of those different rows, have a look at the keys, and if the key was identical for rows, we basically added them up. So far we covered how we can read data. Of course, we can also write data to a text format. For an example, let's head over to our terminal and let's use our read CSV function again. As before, we're going to read in example 5, and we can have a look at our data frame. Now, if we want to then write out our data, we can go ahead and we can use the toCSV function, and we can specify the name under which we want to save that file. So in this case, we're going to save it inside of the examples folder, and we're going to call the file out.csv. And after that, we could, of course, either navigate to the folder and then just double click in order to open it, Or alternatively, we can also open it directly from our terminal. So in this case here, we can call cat and then the name of the file, so out.csv. And this is going to give us back the CSV file we just created. And we can see it's separated by comma. And of course, we have the same values as inside of our data frame that we defined. And again, under Windows, you would not use cat, but type instead in order to display that information. Now, rather than saving the file as a CSV file, we can use other delimiters. For example, in order to print it out to the console rather than saving it as a file. To do this, we're going to import the sys module. And then we can say we want to use our toCSV function as before, but this time we are not going to provide a file name, but instead we are going to say we are going to write it to standard out, so to our console. And we're going to separate it not by a comma, but by a vertical bar. So in this case, we can see we get the output here directly in our terminal, and we have those vertical bars separating our different values. Now in this output here, missing values, as we have them over here, appear as just empty strings. So it's not very visible that values are missing here. So to make that more explicit, we could say that we want to represent missing values as the string null. So in this case, it's much clearer which values are actually missing. Now, files can of course have a number of different delimiters when we work with them. It is possible to load most forms of tabular data from disk using functions like our readCSV function that we worked with so far. But in some cases, it's a good idea to do some manual processing before we can properly read and work with the file. So let's have a look at an example, and let's take a look at example 7. And here we can see we have a number of different strings, which are separated by commas. And so for any file with a single type delimiter, so a comma in this case, we can use the CSV module. So let's write import CSV in order to import our CSV module. And then we can use the open function in order to open our file. And we're going to save that in the variable f. After that, we can use the reader method, which is part of the CSV module, and we can pass our variable as an argument to it. After that, we can iterate over each of the lines inside of our reader object, and we can print out the lines. So this is going to give us back each line as a list. And once we're done working with that file, we can simply call the close method here in order to close our file. Now, when we work with the CSV module, we can also put the data in a format that we want to work with. So in this case here, we are going to open exercise 7 CSV, and we're going to call reader, which is part of the CSV module, and we're going to turn the result into a list and save it in our lines variable. We can then go ahead and split the lines into the header line, which is simply the very first line that we can denote by index 0, and then as a values line, which are all the other lines. After that, we can go ahead and we can create a dictionary of values by using dictionary comprehension, as well as a zip method. So if we do that and we then have a look at our data dictionary that we created, we can see that the header line is now the key and all the other lines are inside of a tuple and associated with that value. So if we compare that again to our original file, we can see that we have the header row here, and each of those entries, A, B, and C, are now the different keys that we have here, and all the other rows are included inside of a tuple. CSV files come in many different flavors, and we can define a new CSV format using, for example, a different delimiter or line terminator. And in order to do that, we can define a new class, myDialect, which is going to be a subclass of csv.dialect. So here we can specify, for instance, that the line terminator should be a new line, our delimiter should be a semicolon, and so on and so forth. And now in order to work with our CSV dialect that we just defined, we would go ahead and use our reader method, which is part of the CSV module, and we're going to specify our dialect as an additional argument. So if we now open our file again, we can then go ahead and use the reader method, which is part of the CSV module, and as an optional argument we can specify our dialect as a dialect that should be used. And there are a number of different options available when we want to work with a dialect. So we saw delimiter before and also line terminator, but we can also specify, for example, that we want to skip the initial space. So far we worked with regular CSV files, but when we work with APIs, for instance, we're going to see that a lot of the data is actually going to be in JSON. JSON stands for JavaScript Object Notation, and is basically the standard format for sending data by HTTP requests when working with APIs. So let's have a look at an example. Here we are defining a new JSON object. In this case, we are using Python's multi-line string, denoted by 3 quotation marks and also ending with 3 quotation marks. And inside of that, we are basically using a dictionary where we have key value pairs which are denoted as strings. And JSON is very close to valid Python code with some very small exceptions. For example, the null value is expressed differently. Now, in order to work with JSON, we can go ahead and first import the JSON module. And then we're going to use JSON's load function in order to load an object. So the object we just defined before, we can pass as an argument to the loads method, and we're going to save the result in a variable. Now, if you have a look at the result, we can see that this is our output. So here we have our dictionary with the different key value pairs that we specified inside of the JSON object that we defined before. So using this loads method, we converted a JSON object into Python. We can also do the reverse, so converting a Python object back into JSON. For that, we are going to use the dump method, which is also part of the JSON module, and we're going to pass our Python dictionary as an argument. So if we now have a look at our JSON object here, we can see the result is very similar, but this is actually a valid JSON object. Now, in order to use JSON for data analysis, we of course need to convert it into a data frame. So for that, we can create a new data frame. In this case, we are going to take a subsection of our JSON object. Specifically, we are going to have a look at the value for the key siblings, and we're going to specify the columns to correspond to name and to age. So if we now have a look at our data frame that we just created, we can see that we have 2 columns, name and age, with the associated values which have been extracted from our JSON object. There's also a way to easily convert a JSON object directly into a series or a data frame. For that, let's have a look at an example. Inside of our examples folder, we have a JSON example that looks like this. And we can use pandas readJSON method in order to read such a JSON file and then turn it into a data frame. So if we now have a look at data, we can see our JSON object here has indeed been turned into a data frame. And if we need to export a data frame as JSON, we can use the toJSON method and then, for example, specify that we want to print it out to the console by using standard out. So this is going to give us back the result as a JSON object. Now, when we want to read some data from the internet, in addition to using JSON, when we work with APIs, we can also use web scraping and read out XML or HTML data. And Python has many different libraries we can use for that. For example, Beautiful Soup or HTML5lib. And Pandas simplifies this by having a built-in function called readHTML, which uses all of these different libraries to automatically pass tables out of HTML files as data frame objects. And to see how this works, in our examples folder, we have a downloaded HTML file. In order to parse it properly, we can first switch back into our terminal, and we can then go ahead and use conda to install the different libraries we're going to use, which are LXM, Beautiful Soup mentioned before, and also HTML5lib. And it may take a short while in order to install those libraries. Next up, we can use our readHTML function mentioned before, which is also part of Pandas, and we're going to read in an example HTML file, which is located also inside of the examples folder. Now, first of all, we can have a look at the length, so we can see there's one entry here. And Pandas readHTML function has a number of different options, but by default, it tries to read data contained inside of the table stack. So in order to create an HTML table, in this case, we can see we have a single table included in that HTML page. So let's have a look at that table, and since these tables are stored in a list, we need to index the first entry, and we're going to save it in failures because our website here is about a list of failed banks. Next up, we can use the head function on failures, and here we can see the different head information. So for instance, the bank name here and also the update date. So from here we could proceed by doing some data cleaning and analysis. So for instance, we can use the toDatetime function to have a look at the different closing dates. And we can have a look at the year when the bank's closed and also count the number of values for that. And then we can see 157 banks closed in 2010. In 2009, we had 140 banks that closed, and so on and so forth. And we're going to cover data cleaning and analysis in a lot more depth in a later video. Now, aside from HTML, which of course is used for website, XML is another very common structured data format, which supports hierarchical and nested data with metadata. And we saw before how we can use the readHTML function in order to read data using one of the different supported libraries. Now let's have a look at an example where we use a specific library, specifically LXML. So as an example, we have some data from New York's Metro Authority, and the data looks something like this. So for instance, we have the agency name here, we have a description, and we also have the year and the months. So to start using LXML, we are going to import it first. Specifically, we are going to import Objectify from LXML, and then we're going to specify the path to the dataset we just looked at. We can then open our file, and we're going to use Objectify, specifically the path method, in order to parse our file and save it inside of the parsed object. And finally, we're going to call getRoot on our parsed object and saving that inside of root. Next up, we can specify an empty data list, and then we're going to specify which kind of fields we want to skip from the results. Next up, we're going to use a for loop in order to have a look at our root indicator, and we're going to skip those fields here, which are included inside of our skip fields list, and the other fields are going to be appended to our empty data list. Now we can go ahead and use that data list we just created and turn it into a data frame. And if we now use the head function, we can have a look at the first 5 rows, where we have the different agency names displayed, as well as the associated values. Now when we use Panda's readXML function, this turns this process into a one-line expression. So we can have a look at the value we get back, and here we have the first 5 rows of the associated data frame. Now, rather than working with regular text formats as we did so far, we can also work with binary data formats. And a simple way to store data in binary format is to use Python's built-in pickle module. All pandas objects have a toPickle method that writes the data to disk in pickle format. So for an example, let's hop into IPython and let's first create a data frame by using the regular read CSV function that we saw before. We're going to read the data from example1.csv and storing it inside of frame, and this gives us back a regular data frame. But taking this, we can now call toPickle and save this inside of the examples folder under frame_pickle. And pickle files are generally only readable in Python, and we can read this by calling readPickle, which is part of Panda, and then simply specifying the path to our pickle file. By doing that, we can see we now read out our data frame again. Quick note, pickle is only recommended for short-term storage. And Pandas also includes support for several other open source binary data formats. So for an example, if we were going to install the PyArrow package, we can then go ahead and read binary files for Apache's Parquet, which is a data format. So here we have inside of our dataset folder, inside the FAQ folder, a Parquet file, and we can now read out the data basically by having installed the PyArrow package. We can also read Microsoft Excel files, and to do that we again need to install some packages. So we're going to use Conda to install OpenPyXL and XLRD. And once installation is complete, we can read Excel files by using the Excel file method, which is part of the Panda module. Here we're going to read in example1.xlsx, which is of course an Excel file. And then we can, for example, go ahead and list the different sheet names. So in this case, we have only sheet 1, and we can read in data contained in those sheet files by using the path method and then specifying the sheet name. So in this case, sheet 1, and this is going to give us back a data frame with the respective data contained inside of that Excel file. So if you have an index column, we can also specify that. So here we're going to specify index column 0, and we get the respective data frame back. If you're reading in multiple Excel sheets, then it's typically faster to use Panda's Excel file as we just saw before. But we can simply also just pass the file name to our readExcel method here and specify the sheet name. So we can do that in a single line and then have a look at the data frame. Now to do the reverse, to write Pandas data to an Excel format, we must first create an Excel writer object. So to do that, we can call Excel writer, which is part of Panda, and pass the path to a file to it. And then we can use the toExcel method, pass our writer that we generated as an argument, and then the name of the sheet. And then finally, of course, we need to close our writer. If we want to avoid creating a writer object, we can also use the toExcel method and directly pass the file path to it. We can also use HDF5. HDF stands for Hierarchical Data Format, and it is a file format intended for storing large quantities of scientific array data. So to get started, let's switch over to our terminal, and let's make sure that we install PyTables using Conda. Now once that's done, let's also make sure that we import NumPy, and then we can create a new data frame using Pandas. After that, we can use Pandas HDFStore class, and we're going to pass an example to it, in this case mydata.h5, which is a file in HDF5 format. We can then go ahead and associate our frame with the value for object 1 inside of our store variable. And we're going to associate the values with key A inside of frame with object 1 column inside of store. Now if you take a look at store, we can see it's of class HDF store. Now if we want to have a look at the different values, we can for instance have a look at object 1. And here we can see our key A from before and the different values associated with the different rows. Now our HDF store class supports two different storage themes called fixed and table. The default one is fixed. And if we want to add an additional entry to our store object, we can use the put method. And here we are specifying that the format should be of type table. That is a bit slower than the default type fixed, but it allows us to do some query operations. So what we can do with format table is, for instance, this. We can use the select method and we're going to select object 2, but then we are specifying this query syntax. So we're going to select the values where the index is between 10 and 15. And we get the associated values back. And at the end of our operation, we of course should make sure to actually close the file again. We can also interact with web APIs. And we saw before already that we can work with JSON. And JSON is a format that's virtually used by almost all APIs. So in order to work with data provided through APIs, we can use the requests package. So let's jump into our terminal and let's use Conda to install that package. Now once that's done, we can go ahead and we can import the requests module. And let's use this to access GitHub and let's find the last 30 issues inside of the Pandas project. So for that we are first going to specify a URL variable, which points to the Pandas project on GitHub. And then we can use the get method, which is part of requests, and pass a URL to it in order to get a response back. Now the first thing we should do is to actually verify that we got a valid response. For that we can use the raise for status method, which is going to check for the HTML status. Now once we've done that, we can look at response and we can see that response has a value of 200, which means that the HTML request worked properly. Now let's take our response and let's call JSON on it in order to get back a Python object, and we're going to store that inside of a data variable. And now if you want to have a look at the first entry and we are going to look at the title column, we can see that this is the first title of a GitHub issue relating to Pandas that was reported. Now if we want to look at multiple issues, we can create a new data frame object. And here we are specifying 4 different columns: number, title, labels, and state. And now if we have a look at our issues data frame, we can see we have 30 entries, so the last 30 entries. And we can see the number here as well as the state. So this allows us to use web APIs in order to retrieve data and then turn that data into, for example, a data frame and do some further analysis. Now in business settings, a lot of the data may not be stored in text or Excel files, but rather may be contained in databases, such as SQL Server, PostgreSQL or MySQL. And Pandas of course also provides functionality to work with databases. So let's switch into the terminal, and as an example we can go ahead and we can import SQLite 3, which is a very small database. And then we can create an SQL query. So in this case, we're going to create a new database table called test, which has 4 different columns associated. We're then going to use SQLite 3's connect method in order to connect our database. And then we're going to use the execute method in order to execute our database query that we defined before. And finally, we can use the commit method in order to commit our changes to the database. After that, we can insert some data. So here we are defining a new data list that contains tuples of different states and associated data. And then we can define a database query in order to add this data to our SQL database. Since we are inserting multiple values at once, we can use execute many as a method and then pass our query as well as our data as arguments to it. And then let's finally commit our changes. Now of course we can also select data from our database. So here we are executing an SQL statement to select everything from our test database. And we can then use the fetch all method on our cursor object that we defined here in order to specify the different rows. Now if you have a look at our rows, we can see we get back the data object we defined before, which is now stored inside of our SQL database. Getting access to data is often the first step in the data analysis process. We looked at a number of different tools and options in order to read and access data. In the next video, we are going to cover how we can clean the data. Feel free to subscribe to the channel to not miss any videos, and see you guys in the next video.